paper with the title Computer Vision Assisted Palm Representation with Supervised Learning. The outline will be this. Okay, I'll just go through the introduction. So this paper proposed a low-cost computer vision assisted system for palm and finger representation. So they choose the lead motion controller for the sensor because despite from its mobility and range, the lead motion controller can detect precise movement of palm and finger accurately. And they use a machine learning technique to help them to learn the parameters that describe the 3D movements of the hand for the purpose of the fingers and palm rehabilitation. So they also propose the interface of rehabilitation that is capable of analyzing the intermediate steps of rehabilitation without help of the expert and can provide online feedback to the users. And they set up their problem formulation like this. So first, the palm movement or finger can be represented using the first order Markov system. So assume that we have a set of k independent gestures and can be represent the position and the orientation of the palm at a given point of time in the first order of Markov system. So each of the gesture can be represented using the set parameter describing the geometrical structure of the palm. Then they use that for the supervised learning technique of the machine learning to solve the problem by asking the users or samples users to undergoing rehabilitation perform to set the predefined sequence of gesture for the learning of the machine learning of the system. And they have two problems. So first is given time the series representation of sequence using a low level feature, how to segment it into homogeneous region and map them to relevant isolated gestures. The second one is to determine whether the sequence of the gesture is valid or not valid with respect to different set of valid sequence. The main contribution of this paper is segmentation of continuous signal acquired through the lead motion control into the isolated gestures and representation of the gestures using a set of features in the 3D. Learning various parameters of LDA and SPM classifier and training of the HMM for recognition sequence of the gestures and predict the test of the sequence of the gesture. And designing the graphical user interface to facilitate the recording of the gestures, train the system, and to support the self-assessment of palm individual rehabilitation. So the gestures that they want to record, they kind of come out with the design of 8 set of universal gestures that they believe it can cover major types of palm and finger rehabilitation. So the new gestures in the future can be added with a set of address more complex rehabilitation when it's necessary. So this is the, as you can see, that 8 gestures here that they will capture the sample to train and to test later. First, before they training the sample gesture, they need to smooth and segmentation of the gesture. Raw signal cannot be used directly because the noise, so they apply the smoothing filter and they smooth the gestures using these 2 functions. Basically, they just using the mean of the velocity of the fingers of the 20 frames that calculate after several experiments. And in that in that size of the windows, they replace all of the result of the phrase by the mean of response, so it can be smoothing. Then a velocity guided segmentation has been applied to demarcate the region or to make isolate gestures to further state of the palm to localize the start and the end of the point of the gestures. To do that, they use a binary pattern from velocity estimated result that you get from the smoothing. Then they use the binary pattern to separate the gestures, and they use this function. And the velocity threshold they get from the experimenting of 30 people to perform the stable condition with less movement by calculate the max instantaneous velocity of all of 5 figures and multiplied by 1.2. And this binary pattern construct using the smooth version of the signal. So basically it's like this. First the raw signal come and they smooth it using the velocity 2 function that was explained before, and they detect the starting and the end of the gestures by applying the binary pattern. After they doing that, they extract the features. So in the lip motion, we can get the fingers, position, and etc. Directly. So here they choose several features, such as grab strength. It indicates how close a hand is paying a fist. Any finger that not curled or like this will reduce the grab strength. So the value is between 0 to 1, which is the 1 is the full grab. And the angle between the fingers, this angle between fingers and independent factors along with the fingers. So, and then the normal factors of the palm surface. And it represents the factor that point downward or out of the front surface when the heart is flat in X and Y. And the last is magnitude and direction of each finger with the percent of center form. They put that in one set of the feature factor like this. And they also have several additional parameters that, like the proximal phalanx, and intermediate phalanx between the consecutive finger pairs. They not included in here because it's not include the repetition. They will show in the experimental result. So basically it's like this. So this one is the geometrical description of the human palm. It's get from the lip motion. And this is the angle that I mentioned before. And this is the normal factor. And this is the grab strength with the minimum and maximum grab strength as a feature. These features is interesting that maybe I can use it in my works. And there are two problems of the method of the regulation. The first problem is about the identification of the isolate gestures, like a gesture recognition, and it can be solved by supervised classifiers such as BA and SBA. And the second problem is to recognize the gesture sequence. It can be solved, usually it's using HTML fast sequence recognition. So the system, the whole system architecture is like this. So first they acquired the raw signal from the lead motion, they do some segmentation, feature extraction, then they start to training, they use a different, they want to try to compare the two different methods of the isolated gesture recognition, which is using LDA and SVM. And they use the HMM for bots and to train the HMM model, then they can recognize the sequence of information. So there's a two problems. The first is gesture recognition, like one or isolated gesture recognition, and gesture sequence recognition. And they put in the interface that they built for representation. And by using LDA or linear multicast, they use a multi-class linear dimension analysis. There are several three steps. First, the finding into class by using this function, and they find the transformation that maximize, and this transformation can be obtained as solving by the relaxation and further problem from this. And by that, they can directly classify the new input with this equation. With respect to K is the class. Using the